Hey guys, and welcome to Unit 1, Lesson 3. We're not only going to be copying angles here, but we're going to be bisecting them as well. You're going to need to have out in front of you your compass, as well as your straight edge and your protractor. Now your protractor may have a straight edge on it, that's fine. Okay, so let's go ahead and get started for today. First off, some vocabulary terms that you need to be aware of. You should have talked about these previously, but I want to talk about them in the context of our geometry class. So the figure above right here is an angle. It's formed by two rays. Okay, notice I can break this angle apart, and there are two different rays. A ray is a piece of a line that ends on one but continues on forever. So it's kind of halfway between a line segment and a line. Okay. Now the end point that you see here is called the vertex. Okay. That's very important. Now, these two right here are called the sides of the angle. This is going to be important also when we talk about triangles, talking about the different vertices and classifying each different side as far as opposite and adjacent, okay? Okay, and now the angles are going to be measured in degrees. So a 180-degree angle would be a straight line, okay? It's not exactly straight, but you get my meaning. Okay, 90-degree angle, okay, would be a perpendicular right here. Okay, we can write it either as the measure of angle A, as with a little m measure angle A, or you can actually write out the word measure. It's completely up to you. Alright, so the first things first, okay, we need to be able to name and classify different angles. First off, an acute angle is going to be anything between 0 and 90 degrees. Now the angle cannot be 0 and it cannot be 90. That's why there's not an equals to bar here or here. If the angle is exactly 90, no more, no less, we call it a right angle. If it's larger than 90 but less than 180, we call it an obtuse angle. And if it's exactly 180, we call it a straight angle. This right here is 180 degrees. You can remember that because when you draw the angle, it almost looks like half of a circle. And since circles are 360, half of 360 is 180. Alright, so we have two examples here. First off, I'd like to take a look at example number 2. I'm going a little bit out of order, okay? But what I'd like for you to do is take a look at this angle. Okay, we have put the vertex, remember I said it was very important, right here at the center of your protractor. Okay, you might have a little hole in your protractor where that's your code for it. Line up your vertex in this hole, kind of like a scope. Okay, then one of the sides of the angle needs to be set on 0. Okay, so this side I set on 0, and now, whoops, excuse me, from here to here is my angle. Okay, so that's going to be roughly 135 degrees. We're going to do a little bit of estimation. If you said 136 degrees, I would also accept that. If I can get my pen to work here. There we go. Make sure you also put the degree symbol as well. Okay, if you thought it was going to be 44 or 45 degrees, you read the angle backwards. Remember, you start from one side and go to the other. Okay, there's no side of the angle over here. So now what I'm going to do is I'm going to take my protractor and I'm going to put it over here on my example 1 angle. Okay, notice that we line up the vertex with the center, so do the same on your paper. Okay, and then from 0 to, this looks like 36, 35, 36 degrees. Okay, I would accept both answers, something like that, on a test. Alright, so that is how you read an angle. This right here is an acute angle because it's less than 90. This angle would be obtuse because it's greater than 90. Okay, but neither one are 90, which is right, or 180, which is straight. Alright, so we're going to begin by copying an angle. These two slides actually talk about step by step. You should have them sitting in front of you. I'm going to go over them real quickly, but then we're going to try it because it makes more sense when you put the words to the motions, okay? So in order to copy the angle, we're going to start off the same way as before. Step 1, you're going to draw a ray. Remember, a ray is like between a line segment and a line. It ends at one point and continues on forever in another point. Okay, so that's like what we did with the line segments. You start by drawing a line. Okay, then you're going to put the point of the compass on the vertex and draw an arc. So let's go ahead and pause there. Again, there's continuing in slides, and let's go ahead and do what we need to do. Okay, I am going to draw a ray, and I have a fancy line tool, but you should use your ruler. Let's just do that. So it ends at one side, and it goes forever on the other side. Okay? So I am going to put an arrow for forever. Now I'm going to take my compass, and I'm going to open it up and put the pointy end on the vertex, which we have called S in this case. Okay, now I'm going to make an arc from here to here. Okay, now if you go back and look at your directions, step 3 says, in all caps, without changing the compass, place the point on X, which is our vertex of our new angle, and make the same mark. Okay, now what I would do is I would go really far. Notice that this arc is larger than this arc. That's okay. You're going to want to do that. Alright, now what we need to do, and in the directions it says to label the points as T and U. So what I'm going to do is I'm going to label this point U and this point T. That way you understand when you go back for future reference. You don't always have to label the points this way. Okay? So now what I'm going to do, and I'm going to change the color, is I'm going to take my compass and I'm going to measure the width from T to U. So T, oops, I need to turn this a little bit more. So T to U. It's a little too wide. There we go. This is a lot easier on the actual paper. So what you're going to do is once you've got it measured T to U, make a mark. You are then not going to change your compass. So we're on step 5 now. And we're going to go over here, and you see where the arc crossed my ray? Put your point there at the same place. And then mark your arc here. So now we are done with our compass, and you can go ahead and put it away. And all you have to do now is take your straight edge and line up the vertex with the intersection of the two rays. So let's get it all lined up. Again, this is a lot easier to do when you actually have the straight edge in your hand, not on the computer. So that should be close. Okay, there you go. So you drew our ray there. We have copied this angle. Okay, and according to the directions, I was supposed to label. So give me just a second. Alright, so we are going to label the intersection of the two arcs as Z, and the intersection of the arc with the ray we drew as Y. Alright, so how can you use a protractor to check your construction? Okay, what I can do is I can go back to the previous slide and pull out a protractor, and ta-da, like magic, here's my protractor. So what I'm going to do is I'm going to put my vertex in the little hole of the compass, or the protractor, excuse me. I keep messing that up. So with your protractor, go ahead and line up the vertex of the original. Okay, and take a look at the measurement. That looks spot on to be 10, 20, 35 degrees. Okay, so we're going to say 35 degrees. And then we're going to move our protractor over here to the vertex of our copied angle. Okay, and then we're going to go from 0 to 10, 20, 30, wow, 35 degrees. There might be some slight variations. It just depends on, your compass, the pencil width of your compass. Okay, so any number of errors, as long as you're within 1 degree when you're copying, I'm okay with that. Because what I'm going to do is when I see the angles, I want to make sure that those angles are actually correctly defined. Also, I won't just be looking for the angles, I will be looking for these marks right here and right here to show me that you know exactly what you're doing with the compass. Okay, so how can you use a protractor? Basically just measure each angles. They have to be congruent. So if you draw angle X so that its sides appear to be longer than the sides of angle S, are they still the same measure? So take a look over here. Notice that when I drew my ray, the very first step, I made it much longer than SU's ray. And XZ's ray is a whole lot longer than ST. That's okay. Notice no matter how long the side lengths are, the angles that the sides still make are the same. Okay? So that's what we're looking for in number 2. Alright, so take a minute and jot that down. When you're ready, unpause the video and go to the next slide. Alright, so now we have some more vocabulary. We've learned how to copy an angle, now we must learn how to bisect an angle, okay? An angle bisector is a ray. Remember, a ray is a line that stops at one side and continues on forever. So looking at this picture, the ray that is bisecting angle B is BD, ray BD, okay? Now, we can also name angles with 3 letters. So in this case, it's angle ABC. It's really important because sometimes if you say angle B, do you mean this part? Do you mean this part, or do you mean the whole angle? So it's very crucial that you learn that the vertex is always going to be the middle letter of the angle. Notice the vertex is B, it's angle ABC, okay? Because the ray BD bisects it, we know that angle measure ABD, which is here, and angle measure DBC, notice that B was the vertex for both, they are the same measure. That's the definition of bisecting something, is to cut it in half. Okay? So here we are, we have some directions on how to bisect an angle. Okay, you should keep those in front of you as we are bisecting. Okay? So now that I have my compass and straight edge out, what I'm going to do is I'm going to follow the directions for bisecting an angle. First step, it says to place the point of the compass on the vertex of the angle. So we're going to place the vertex, which is labeled M for this angle, because we're bisecting angle M, okay? And we're going to draw an arc that goes through both sides. So like that. All right? Notice it goes clearly through both sides. Okay? It says in these directions that we want to label this point Q and this point P. Again, you don't have to label that. This is just for reference for later. That way you know what we're talking about when you're doing practice problems. You can say, oh, we called that point P. Alright, so then you're going to place your compass on point P. Okay, you can change the compass at this point, or what I like to do is I just leave it. It doesn't matter. And I'm going to make an arc right here somewhere in the middle of the angle. Why in the middle of the angle? Because the bisector cuts the angle in half. So somewhere this bisector is going to cross somewhere in the middle. Now, you definitely can't change your angle for your compass for this. So I'm just going to flip sides, put my point on Q, and make an arc that crosses the previous arc I made. So let's get that. There we go. Now I'm done with my compass. Where these two arcs intersect is my bisector. So I'm actually going to grab a line, okay, and I'm going to go from vertex M all the way through where the two arcs intersect, okay? That right there is what we call the angle bisector, okay? And we're going to label that point R according to the directions. You don't have to label like that. Alright, but how does it look when we bisect an obtuse angle? Okay, when we bisect an obtuse angle, the directions don't change, okay? All that it is you still put your point on the vertex. However, when you create an arc through this obtuse angle, your arc is going to go for what seems like forever because it is an obtuse angle and the angle is much wider. You still have to make sure that your arc goes through both sides of the angle. So with an obtuse angle, you would still take your point and put it on each of the intersection points. However, what I would do is at this point, I would open my compass a little bit wider to get a bigger arc, okay? That's okay. The only time you can't move your compass is between this step and the next one. So go ahead and make your arc. Now, don't change the compass width, right? So just flip it to the other intersection of the arc in the side and draw there. Okay, so now we can put our compass away, get out your straight edge, and draw a line that goes from the vertex through the intersection points of the arc. Oops, I missed my vertex a little bit there. Okay, so there we go. This right here is the ray that bisects our obtuse angle, which means that this side length here is equal in measure to this side length there. Alright, well that's it for today. Tomorrow we will continue on with angles. I will see you then.